one of the things we're expected to know is to be able to simplify a square root. Now this, if you put this into the calculator, press equal, it will do it for you. That's why I'm not going to give you a question like this. I'm going to give you a question which involves a little bit of algebra inside it. So if you like, it could be something like this, the adapted version. It could be, for example, the square root of 300x to the power of 6. There you go. So now, theoretically, you can't really do it in your calculator. So how does this work? Well, if you have something like the square root of 300 times x to the power of 6, the way you would do it is you would break it down into the square root of 300 times the square root of x to the power of 6. Now, this x to the power of 6 is very easy. There's multiple ways to do this. Basically, the square root of x to the power of 6 is equal to x cubed. You can think of it as a logical thing. X cubed times x cubed gives you x to the power of 6. Or you can think of it as something to do with laws of indices. So you could rewrite that power as the power of a half, because the square root is actually the power of a half. So if you wanted to work it out differently, you could say that this is x to the power of 6 and all of that to the power of a half. And then we multiply the powers, so we get 6 times a half, which gives us 3 as a power. So these are two ways to show that the root of x to the power of 6 is x cubed. But now I'm going to focus on the square root of 300. So if you don't use your calculator, and in some cases it's useful not to use the calculator, I'm just going to talk about how you would do it by hand. So you would basically try to rewrite this as a big square number, a large square number times another number. So let me think about this for a second. Square numbers, let's remember that we've got 1, 4, 9, 16, 25, 36, 49, let's see, 64, 81, 100. Oh, there you go. 100 seems to be convenient. So you can rewrite this 300 as the square root of 100 times 3. And then that means we can break it down into the root of 100 times the root of 3. And we know that the root of 100 is 10. So we get 10 times root 3, or just 10 root 3. So what would be the final answer to the square root of 300 times x to the power of 6? Well, it would be
root 3x cubed.
Exactly, nicely done. 10 root 3 times x cubed. We just put the two results together. So 10 root 3 times x cubed. Okay, so this is pretty much the answer to the first question. Let's move on to the next one, which is actually the backwards approach. So imagine what could have been the original root, which led to 3 times root 6. Well, we have to go backwards, because basically think about it this way. We had a root, then we split it into a root times another root, and that gave us 3 times root 6 in this case. So 3 times root 6, all we have to do here is rewrite the 3 as a root of something. And we know that the 3 is the root of 9. So in this case, effectively, we have the root of 9 times the root of 6. Now we can put the 2 into one big root and say it's going to be the root of 9 times 6, which is the root of 54. So that is what root simplifies to give us 3 root 6. Now, moving on to the next one, this is rationalizing the denominator of a fraction, which means eliminating the root from the denominator. When it's a simple case, this is the simple case where you only have one root in the denominator. This is easy peasy, lemon squeezy. All we have to do is multiply the top and bottom by the root we have in the denominator, which in this case is the root of 5. Okay, so what does that give us? It gives us 40 root 5 in the numerator, and it gives us root 5 squared in the denominator. Now, a lot of students like to think that root 5 times root 5 is equal to the root of 25, and that's equal to 5. And that's fine, it works just fine, not a problem, but it's not very convenient when you're given something like this, the square root of 2021 times the square root of 2021. It wouldn't be the most convenient approach to do 2021 times 2021, because then that would give you the square root of 84,441. And then how would you find the root of this? You'd have to put it into the calculator. So it's not very good as an approach. It would be better to think that it's the square root of 2021 squared, which then you know the root and the square simplify, they cancel each other out, so you get 2021. So where am I getting with this? I'm getting to this. When you multiply the denominator by the root, you just simply get rid of the root and you're left with the thing which was undone. the root. So in this case, you're left with just 5 in the denominator. Okay, so avoid multiplying the things under the root. Just say it's the root, all of that squared. Just cancel the root with a square because they are anti-heroes. So we're left with this lovely thing. Most students would be super happy here. They'd write 40 root 5 over 5, but they would be wrong because we want to simplify this further. Notice how the 40 can be divided by 5. And we know 40 divided by 5 is 8. So we can just write this down as 8 root 5. So keep an eye out, please, when you simplify, when you rationalize, to simplify the fraction if possible. So moving on to the harder case. So this is the harder case of rationalization. And guess, of course, I gave you a question like this. I've put a question like this in your graded task because I am evil. Okay, so here, actually, I'm not really sure I've put it in now that I think about it. Anyway, it's highly likely I put it in, but I'm not 100% sure now that I think about it. Because I thought if I give you this question, you will just basically type it into the calculator and get the answer that way. So I wouldn't want to do that. But in any case, I'm going to show you here. I don't really remember if I gave you a question like this or not. So this is 3 over root 7 minus 1. How do we rationalize this? So the trick here is to multiply by something called the conjugate, which is basically the same thing we have in the denominator, but with a different sign. So instead of root 7 minus 1, we have root 7 plus 1. So this is the conjugate. We've got a special name for it, conjugate. I even looked up the etymology of this. It's really weird. Apparently there's a verb in Latin called jugare, which means to yoke together, put together. So I don't see how this is called the conjugate of that. But anyway, the conjugate of root 7 minus 1 is root 7 plus 1. So if you had a minus here, you put a plus here. If you have a plus here, you put a minus here. That's simple. Right, let's go ahead and calculate this. Well, what do we get in the numerator? So first things first, here, most students want to expand the brackets. Don't do that. If you expand the brackets, you will miss an opportunity to simplify the fraction further later. So what I'll do here is just rewrite it as 3 times the bracket root 7 plus 1. In the denominator, what is this going to give us? Well, you could just expand double brackets if you want to. You could do root 7 minus 1 times root 7 plus 1, expand all the terms, write down what you get from each of them. But I'm not going to do that. I'm going to use a nice little trick which says a minus b times a plus b is equal to a squared minus b squared. So basically in this case, yeah?
And then you just put it over 6.
Exactly, nicely done. Basically, root 7 squared minus 1 squared, it basically gives you 6. And someone else might say, oh, I've used the better method, sir. I just put it into the calculator and it gave me 6. Hats off to you, whoever you are, hypothetical student. So here we've got 3 and 6 down here. Most students will be happy to just leave it like this. But this is an opportunity here to simplify. Notice how 3 and 6, we can actually simplify them by dividing them both by 3. So if you divide by 3 and you divide by 3, then what you get is just root 7 plus 1 in the numerator and 2 in the denominator. So that would be your final answer here. Once again, the smartest one of everyone in the group just took this, put it into the calculator gave him this. Well done to you, hats off to you. But when you've got a little bit of algebra here, an x here, a y here, you'll have a bit of an issue putting that into the calculator. Right, moving on to laws of indices. So this topic here is called laws of indices. Basically, we've seen this stuff for GCSE, but we're doing a crash course here. So how do we simplify this expression 2m to the power of 4 and all that raised to the power of 3? The calculator cannot do it for us, so we have to use our brains. Now, how does this work? Basically, you could do the slow method. 2m to the power of 4 cubed means 2m to the power of 4 times 2m to the power of 4 times 2m to the power of 4. And just do it. I would call this the slow method. It doesn't work very well when you have to the power of 2021. So I would avoid this method. I would recommend the other method, which basically says if you have two things and the multiplied and raised to the power of n, then that is a to the power of n times b to the power of n. So in this case, 2m to the power of 4 and all that to the power of 3 is equal to 2 to the power of 3 times m to the power of 4 to the power of 3. So this is my A, this is my B. So what do I get from that? 2 cubed.
So I think you switched the 4 and the 3.
Sorry?
I think you accidentally switched the 4. Oh no.
No, the 4 is inside and the 3 is outside, right? So the 4 is
I switched.
okay, be careful not to switch the numbers around. Phew, I thought I made a mistake there. Right, so 8 times. Now this business here, m to the power of 4 to the power of 3. Here, we have to remember this rule which says if you have a to the power of m and all of that is raised to the power of n, then we have to multiply the powers together. So this is one of the rules we are using here, and the other rule we used previously, I'll put them in little bubbles so you got them separated. So here, this will become m to the power of 4 times 3, which everyone here knows, hopefully, that 4 times 3 is 12, so we just get 8 m to the power of 12. Why didn't I put the times there? Because I'm lazy. I don't like putting times there, so just write it down this way. Okay, moving on to the next one. I'm sure everyone is on board. I've got 3 more questions to do. So here, basically, we have a fraction with multiple terms. What do? I'll use 3 colors to keep things simple, to clarify things. The 10 is divided by the 2. The m to the power of 5 is divided by the m to the power of 2. And the n to the power of 4 is divided by n. So that's pretty much how we will simplify this. So we'll have a fraction line. Now, what is 10? Actually, we don't need a fraction line anymore. I'll get rid of fraction completely. Now, 10 divided by 2 is 5. So we'll just go ahead and write down 5. M to the power of 5 divided by m to the power of 2. Remember that rule which says, well, if I have a to the power of m divided by a to the power of n, I have to subtract the powers. So let's put in a little bubble, is the property we're using here. So this will be m to the power of 5 minus 2. You see the invisible times I put there? There's a times. If you can't see it, it's because it's invisible. And then moving on to the last one. Again, I'm going to put an invisible times here. N to the power of 4 divided by n to the invisible power. Let's remember that the invisible power is the power of 1. Then we have to do n to the power of 4 minus the invisible 1. And that's pretty much it. If we simplify here, 5 minus 2 and 4 minus 1, we get the final answer. So the final answer will be 5 m to the power of 3 n to the power of 3. And that is the way the cookie crumbles. Now let's move on to the last question here from this page. Don't get excited so quickly. We've got another page, a final example, one more after this. I'm going to use the same property. So the cloud from 2 columns to the left, a to the power of a times b to the power of n, basically everything is raised to that power. So here in this case, 8 is raised to the power of 2/3. I'm going to put in brackets to make it clear. And then x to the power of 6 gets raised to the power of 2/3 as well. Now, if I were doing this without using my calculator, which I am, I'll show you the rule I'm going to use here. You don't have to do it this way, but I'm going to mention it. There is a rule which says that a fractional power is equal to, if you have m over n, it's the nth root of a, and all of that raised to the power of m. So basically, I'll put this in a little cloud. You probably have forgotten all about this rule. The good thing about your calculator is it will tell you what this is equal to, so that's fine. The calculator will tell you this, but it won't tell you this. So let's see how it works. So a to the power of m over n, it would be, in this case, the cube root of 8, and that raised to the power of 2. And I'm going to save the other one for the next step. Okay, now cube root of 8 is 2. So basically, we end up getting 2 to the power of 2 here. That's 2 raised to the power of 2. Now, for the next one, x to the power of 6 to the power of 2/3, you can see, I think, here that we are using the rule from the little cloud on the left, the previous column. Sorry, not this one. 2 columns on the left. When you have a to the power of m, and all of that raised to the power of n, all you have to do is multiply these 2 powers together. So in this case, we're going to go and multiply the 6 with the 2/3. So we get 6 times 2/3 in the index, the power. So this gives us 4 times x to the power of 12 over 3, which simplifies to 4 times x to the power of 4. And that would be the final answer for this particular question. Moving on to the most exciting example in this list of examples, it's going to be basically pretty much the same question as one of your questions on Dr. Frost, but with different numbers. So super important that you pay attention here. So anyone who's muted me and gone out to play Candy Crush or Call of Duty, please unmute me and pay attention here. So here we've got 125x to the power of 5 over 7. We can't do much about this, but there is something underneath, which is 125x to the minus 2 and all that to the 3/4. So you're like, what do I do here? Well, this denominator, we use the same rule as before, a times b, that's a times, a times b, and all that to the power of n, is a to the power of n times b to the power of n. So let's go ahead and do that. So this is going to give us 125x to the power of 5/7. So I'm not changing anything in the numerator, but the denominator will give me 125 raised to the power of 3/4 times x to the minus 2 raised to the power of 3/4. Now, for those who are really, really smart, those who are very intelligent among us, that doesn't include me because I won't do it this way. But those who are really sneaky and smart here, they'll just type this into the calculator and get an answer straight away for this particular thing. I'm going to put it in a little bubble. Whereas the other one will have to be done manually. So if you want to do it this way tomorrow, that's absolutely fine. Basically, keep this in mind. The algebraic bits, the calculator doesn't know how to do because the calculator doesn't know how to do algebra, but it does this bit. So what do we get from this? Let's see. Numerator stays the same, 125x to the power of 5 over 7. Denominator now, 125 raised to the power of 3/4. So if you put this into the calculator, it will tell you straight away, but I'll do it using the rule I mentioned previously, that a to the power of m over n is nth root of a, and that raised to the power of m. So here, that is the quartic root of 125, and all of that raised to the power of 3. Fourth root, or quartic root of 125, is equal to 5. Because 5 times, or is that 125? Actually, sorry guys, I think I meant to put a 6 there. Just give me a second. That is a 6, because otherwise the numbers won't be nice. So that is a 6, that is a 6. Sorry, I came up with this question right before the lesson, so I was a bit rushed. So that is 6 in there, just to make sure the numbers work out fine. There you go, all cooked up now. Okay, so the quartic root of 625 should be 5, because 5 times 5 is 25, times 5 is 125, times 5 is 625. So here we've got 5 raised to the power of 3, basically, which gives us 125. So in the denominator, we have 125. See what I've done there, 125 here, 125 here. I'm so proud of this. And then times, what do we do with the next bit, the algebraic bit? X to the minus 2 to the 3/4. So here we are using the other property, which says a to the power of m, and all of that to the power of n is just a to the power of m times n. So we just multiply the powers. Let me put the properties into little clouds for those who want to pay attention to this. Now, coming back to this, we are multiplying the powers, so minus 2 times 3/4 times 3/4. Okay, so firstly, the most pleasant thing in maths, let's cross out these two, because they're the same. So pleasant. So then we get x to the power of 5 over 7. And then underneath we have x to the minus 6/4. So here we could either go ahead and do the property straight away, but I'm a bit picky about this thing. I'm a bit annoyed by this. I want to simplify it first because I don't like complicated numbers, like 6 over 4, so complicated. Let's go ahead and simplify that. So we get minus 3 over 2. I feel so much better now. Okay, so now what rule are we going to use here? A to the power of m divided by a to the power of n is equal to a to the power of m minus n. So this is a property we are going to use here. So basically we do x to the power of 5/7 minus 3/2. And that equals not very well aligned with. There you go, I'm going to do it this way. Right, so this is what we have to do, x to that power. Now this power here, for those who they want to show off, they can do it by hand, but you can actually put this into the calculator. And that's what I'm going to do because I want to save a little bit of time here. So 5 over 7 plus 3/4, because the minus becomes a plus. So that gives us apparently 31 over 14. So that would be your final answer here. So that's equal to x to the power of 31 over 14. What brilliant numbers I came up with here. I'm going to stop the recording here, and I'm going to give you the opportunity to ask any questions, and I'll help you if you have any issues.